Students, so welcome to fourth day session. So we completed first level basics in inverse trigonometrical functions. Today we'll complete the exercise 2.1 in your textbook, exercise 2.1. So what I'm observing in these regular classes, maybe you are listening to us through mobile or laptop or desktop or smart TV. Many of you are not writing the notes. If you are not writing the notes, so almost all these classes will be waste for you. So I already instructed you people, follow these classes like regular classes. Then only this 8 to 12 will be useful to you, and there is a purpose for our hard work. You are neglecting. See, today we'll see how many of you will follow the solutions of these problems. Write the notes perfectly, practice it for the next class. Here there is no weekend test for you. There is no monitoring of regular classes like in regular sections. So I'm requesting the parents also. You have to take care of how they are listening, whether they are writing the notes or not, whether they are practicing or not. Earlier, that is the responsibility of lecturer. Now it is the responsibility of the student and parent. So our duty is just, without wasting our time, just will teach the lesson here. Just will teach the lesson. So remaining work, how you are following, preparation, and we'll release the assignments also, how you are practicing. If you do all these things only, these classes will go truthfully. Minimum it takes another 2 months. Another 2 months, definitely there will not be a chance to go for regular classes. So out of 12 months, if you are losing 2 months, means your batch will affect so much in PUC results, even in KSET and NEET and JEE mains. So my sincere request to all the students and all the parents, strictly follow these classes and write the notes and follow our guidelines. Then only it will be useful for you. It takes 2 months or 4 months, 5 months, 6 months, we don't know. So don't expect the days. There is no any predictions here when we are going to start the classes. So preparing these classes perfectly. Only my observation, I am receiving the phone calls, only 30 to 40% students you are serious. Remaining all just you are doing comedies with this online classes. So be serious, sincere request. Even I am requesting the parents also. Parents, dear parents, take care of your ward preparation. It is a critical situation, we know it. So take care of your ward preparation. Today we'll start the exercise 2.1. Exercise 2.1 problems. We'll solve the problems. Very simple. Find the principal values of sine inverse of minus 1 by 2. See, find the principal value of sine inverse of minus 1 by 2. Yesterday we practiced sine inverse of minus 1 by 2 formula, sine inverse of minus of x formula, minus of sine inverse of 1 by 2, minus of sine inverse of 1 by 2. We know the sine inverse of 1 by 2 value. What is that value? Minus of pi by 6. That is the answer. One more question, important questions. So the second problem. Cos inverse of root 3 by 2. Cos inverse of root 3 by 2. Try to solve yourself all the problems if you're having textbook. Cos inverse of root 3 by 2. Listen to me. Directly you can write the answer. Cos inverse of root 3 by 2 value how much? This is also pi by 6. Next. Already we completed these examples. Third one. Cosecant inverse of 2. Cosecant inverse of 2. This can be written as simple sine inverse of 1 by 2. That is better. Sine inverse of 1 by 2. Immediately you'll get the idea. What is the sine inverse of 1 by 2? By using the formula cosecant inverse of x is equal to sine inverse of 1 by x. So sine inverse of 1 by 2. What is its answer? Pi by 6. Next, third one. Fourth one. Find the principal value of tan inverse of minus of root 3. Tan inverse of minus of root 3. What is the tan inverse of minus of x formula? Tan inverse of minus of x formula. Minus tan inverse of root 3. Minus tan inverse of root 3. So this is equal to minus of tan inverse of root 3. What is tan inverse of root 3 value? Pi by 3. Minus pi by 3. That's why already I gave these examples for you. Practice those examples. See the fifth problem. Cos inverse of minus 1 by 2. See the important problem. Cos inverse of minus 1 by 2. What is cos inverse of minus of x formula? Pi minus of cos inverse of x value 1 by 2. Applying that formula. Cos inverse of minus 1 by 2. Here you will do the mistakes. Simply you will write minus cos inverse of 1 by 2 and you will write the answer. That is wrong answer. Pi minus of formula. Pi minus of cos inverse of 1 by 2. So what is cos inverse of 1 by 2 value? Pi by 3. So pi minus of pi by 3. 2 pi by 3. Cos inverse of 1 by 2 value pi by 3. Sin inverse of 1 by 2 value pi by 6. Don't get confusion. Tan inverse of sixth problem. Minus 1. Complete this one simple problem. Tan inverse of minus 1. Tan inverse of minus 1. Minus of tan inverse of 1. Minus of tan inverse of 1. So that is minus of tan inverse of 1 value. We know it, pi by 4. Minus pi by 4. Simple problems. From this area you can expect the 1 mark problem. Seventh one. Find the principal value of secant inverse of 2 by root 3. Secant inverse of 2 by root 3. Generally students, you are not familiar with the secant inverse values. So converting to cos inverse. Secant inverse of x is equal to cos inverse of root 3 by 2. What is cos inverse of root 3 by 2 value? Cos inverse of root 3 by 2 value. Very simple. Pi by 6. When cos pi by 6 value root 3 by 2. So cos inverse of root 3 by 2 value pi by 6. Find the principal value of cot inverse of root 3. Cot inverse of root 3, x value greater than 0. So we can apply this formula. tan inverse of 1 by root 3 it is. Tan inverse of 1 by root 3. So what is tan inverse of 1 by root 3 value? Pi by 6. See the ninth problem. Find the principal value of cos inverse of minus 1 by root 3. Cos inverse of minus 1 by root 3. 1 by root 2. Complete yourself. Simple problem. So first, cos inverse of minus of x formula. Yesterday we proved pi minus of cos inverse of 1 by root 2. Pi minus of cos inverse of x formula. What is cos inverse of 1 by root 2 value? Cos inverse of 1 by root 2 value. Pi by 4. So 4 pi minus 3 pi means 3 pi by 4 answer. So that find the principal value of cosecant inverse minus root 2. Right. Cosecant inverse of minus root 2. So this can be written as sine inverse of minus 1 by root 2. Converting to sine inverse, cosecant inverse. Cosecant inverse of x is equal to sine inverse of 1 by x. Sine inverse of minus of x formula minus sine inverse of 1 by root 2 minus sine inverse of 1 by root 2. So minus of sine inverse of 1 by root 2 value. What is sine inverse of 1 by root 2 value? Pi by 4 minus pi by 4. Complete. Next problem. See the 11th problem. Eleventh problem. Find the value of a tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. So find the value of tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. Try yourself. Try yourself. So tan inverse of 1, directly we can write the answer. What is this one? Pi by 4. Cos inverse of plus cos inverse of minus 1 by 2 value. Pi minus of cos inverse of 1 by 2 plus sine inverse of minus 1 by 2. It is minus of sine inverse of 1 by 2. Now see this. Pi by 4, see the simplification, plus pi minus of cos inverse of 1 by 2 value, pi by 3 minus sine inverse of 1 by 2 value, pi by 6. Now see this one, minus pi by 3 minus pi by 6 value. This is 30 degrees, this is 60 degrees and 30 degrees. Minus pi by 3 minus pi by 6 value minus pi by 2. So this is equal to pi by 4 plus pi minus pi by 2. Pi minus pi by 2 value, pi by 2. So this is equal to pi by 4 plus pi by 2. pi by 4 plus pi by 2. What is the LCM for 4 and 2? 4 it is. 4 takes 2 only one time. Pi plus 2 takes 2 times. It is 2 pi. Pi plus 2 pi. It is 3 pi by 4. So final answer for this problem is 3 pi by 4. Find the value of tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. Mathematics means practice is required. Just you are listening to me means no use for you. Practice, write the notes. Next, now done 12th problem. Cos inverse 1 by 2 plus 2 sin inverse 1 by 2. See the cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Try yourself. Cos inverse of 1 by 2 value first. Directly pi by 3 plus 2 into sin inverse of 1 by 2 value pi by 6. 2 takes 3 times. Pi by 3 plus pi by 3 value 2 pi by 3. So this is a 12th problem. Simple. Just all are 1 mark questions it is. So go to the next problem. 13th problem. Sin inverse of x equal to y. Then objective question. Right. First option. Tell me first option. 0 is less than or equal to y less than or equal to pi. See the first option. Second option. Objective case. Minus pi by 2 is less than or equal to y is less than or equal to pi by 2. Next, third option. 0 is less than y less than pi. Fourth option. Minus less than y less than pi by 2. See the case set. In case set you will get this type of questions. Simple question. Sin inverse of x is equal to y, then which option is correct? If sin inverse of x is equal to y means, first you should have an idea what is x. Note down that one first. X belongs to closed interval minus 1 to 1. Y means range. Y belongs to closed interval minus pi by 2 to plus pi by 2. Now decide the answer. We required y value. See the 0 less than or equal to y less than or equal to pi means this is closed interval 0 to pi. This is not the answer. If open interval 0 to pi, this is not the answer. Minus pi by 2 less than or equal to y less than or equal to pi by 2 means this is closed interval minus pi by 2 to plus pi by 2. Last option is open interval minus pi by 2 to plus pi by 2. So this is also not answer. So what is the correct answer? Closed interval minus pi by 2 less than or equal to y is less than or equal to pi by 2. Here you should have knowledge about intervals also. Just note down intervals knowledge. If first one, If x belongs to open interval a comma b, that implies, what is the meaning of this one? Means a is less than x is less than b. We have to exclude a and b, and remaining all elements we have to take. Second one, x belongs to closed interval ab means the meaning of this one is that implies a is less than or equal to x is less than or equal to b. Third one, x belongs to left open right closed. Left open right closed means a is less than x is less than or equal to b. And x belongs to left closed right open. Left closed right open means that implies a is less than or equal to x is less than b. Practice these intervals. It is not a finite set. See this one. Open interval a comma b means we can represent like this: a comma b, open interval a to b. All these elements, but a and b are excluded. Closed interval ab means included. A and b are included in the set. All these elements. So it is not a finite set, it is infinite set. That is the meaning of closed interval and open interval. Now the last problem. Exercise 2.1, last problem. Tan inverse of root 3 minus of secant inverse of minus 2 is equal to, options given up. First option, pi minus pi by 2, pi by 3. Third option, pi by 3, 2 pi by 3. Right? One more objective question. Tan inverse of root 3 minus secant inverse of minus 2. Once this problem is given wrong in PUC, they have given secant inverse of minus of 1 by 2. Secant inverse of minus of 1 by 2 and undefined. By printing mistake, instead of minus 2, they have given minus 1 by 2. See the solution for this. Tan inverse of root 3. What is the tan inverse of root 3 value? Pi by 3 minus secant inverse of minus 2 can be written as cos inverse of minus 1 by 2. I am always converting cot, secant, cosecant in terms of cos, sin, tan. Cos inverse of minus of 1 by 2. So this is equal to pi by 3 minus of cos inverse of minus of x formula. Pi minus of cos inverse of 1 by 2. In case it also within 30 seconds you can solve this problem. So this is equal to pi by 3 minus of pi plus minus of minus plus cos inverse of 1 by 2 value, pi by 3. Pi by 3 plus pi by 3, 2 pi by 3 minus of pi. And LCM is 3. 2 pi minus 3 pi minus of pi by 3. So what is correct answer here? Second option. Simple K-set problems. You can expect these questions in a K-set. So that is all about some simple fundamentals and exercise 2.1. Now done, important results. Next. Set 5. Yesterday up to set 4 we completed. This is set 5. Another important set 5. Very, very important result. Prove that, prove that, prove that sine inverse of x, sine inverse of x plus cos inverse of x, this is equal to pi by 2. Sine inverse of x plus cos inverse of x is pi by 2. Here x belongs to closed interval minus 1 to 1. Because the domain of the sine inverse of x value closed interval minus 1 to 1. To define the cos inverse of x also, x belongs to minus 1 to 1. Here you have to observe one point. Sine inverse of x, this is also x. That x must be belongs to closed interval minus 1 to 1. Then only it is pi by 2. These values, two values must be equal, and that value must be in between closed interval in that interval minus 1 to 1. Then only this theorem is applicable. Not done. Proof is important for 2 marks question. Another 2 marks question it is. To prove, we have to prove this one. Sine inverse of x plus cos inverse of x. Let this is one angle, this is another angle. Sum of these two angles we have to prove pi by 2. So I am assuming the first one. Let sine inverse of x is equal to theta, some angle theta. Just we are assuming. Afterwards we will eliminate that theta. So let sine inverse of x is equal to theta. So x is equal to sine theta. X is equal to sine theta it is. So we have to relate sine inverse and cos inverse. So in what way we can express the sine theta in terms of cos? Cos of sine theta can be written as cos of pi by 2 minus of theta. Cos of pi by 2 minus of theta. Sine theta can be written as. Applying inverse function definition here. Just applying the inverse function definition. Cos inverse of x is equal to, cos inverse of x is equal to pi by 2 minus of theta. Shifting that minus theta to left. So theta plus cos inverse of x, this is equal to pi by 2. Theta plus cos inverse of x is equal to pi by 2. What is theta value? We assumed already. Let this is equation 1. What is theta value? Sine inverse of x. Just write that value. So sine inverse of x plus cos inverse of x, this is equal to pi by 2. This is the result. Sine inverse of x plus cos inverse of x is equal to pi by 2. Now done. Second result. Prove that tan inverse of x plus cot inverse of x, tan inverse of x plus cot inverse of x, this is also pi by 2. This is also pi by 2. Here x belongs to R, the domain of the tan inverse of x, x value R, the domain of the cot inverse of x, x value is R. Same way, prove it, very simple. Anyone you can take, either tan inverse of x or cot inverse of x. Assuming that one has a theta, follow the same rules. Let tan inverse of x is equal to theta. So applying the definition, inverse function definition, x is equal to tan theta. Tan theta can be written as in terms of cot of pi by 2 minus of theta. In first year in allied angles, you know this formula. Cot of 90 minus theta, tan theta. Same. So that is cot inverse of x is equal to pi by 2 minus of theta. Cot inverse of x is equal to pi by 2 minus of theta. Shifting minus theta to left, theta plus, next step, theta plus cot inverse of x is equal to pi by 2. Theta plus cot inverse of x is equal to pi by 2. Write the theta value from the equation 1, we assumed already. What is theta value? Tan inverse of x. So tan inverse of x plus cot inverse of x, this is pi by 2. Tan inverse of x plus cot inverse of x is pi by 2. Guess the next theorem. Prove that secant inverse of x plus cosecant inverse of x is equal to pi by 2. Complete the third theorem. Third one. Prove that secant inverse of x plus cosecant inverse of x, this is equal to pi by 2. Here x belongs to r minus of minus 1 to 1. We know the domain of the secant inverse of x, that is x value r minus of open interval minus 1 to 1. In cosecant inverse of x domain also, x belongs to r minus of minus 1 to 1. A similar way, complete the proof. We know the secant of 90 minus theta, cosecant of 90 minus theta, secant theta, using that formula. Let secant inverse of x is equal to theta. Let x is equal to secant theta. Secant theta can be written as cosecant of pi by 2 minus theta. Go to the allied angles formula list. Shifting this cosecant to left. Cosecant inverse of x is equal to pi by 2 minus of theta. Pi by 2 minus of theta. Shifting that theta to left. So theta plus cosecant inverse of x, this is equal to pi by 2. Write the theta value from the equation 1. What is theta value from the equation 1? Theta value, secant inverse of x. So secant inverse of x plus cosecant inverse of x, this is equal to pi by 2. Secant inverse of x plus cosecant inverse of x is equal to pi by 2. So 3 important results. Just practice. How you will get the questions, note down examples based on this. In KSET or a PUC, how to use this formula list directly. So many times, especially in KSET, Based on this one, they are giving the questions for you. So just note on the simple examples. Example 1. Sine inverse of 1 by 2 plus secant inverse of 2. Sine inverse of 1 by 2 plus secant inverse of 2. See this one. Sine inverse of 1 by 2 plus secant inverse of 2 can be written as cos inverse of 1 by 2. Secant inverse of x is equal to cos inverse of 1 by x. So sine inverse of 1 by 2 plus cos inverse of 1 by 2. So this is equal to, directly you can write the answer pi by 2. So always sine inverse of x plus cos inverse of x 1 by 2, tan inverse of x plus cot inverse of x is 1 by 2, secant inverse of x plus cosecant inverse of x is 1 by 2. And note on here, important note, conversions. If one value is given in terms of sine inverse of x, how to convert it to tan inverse of x? Conversions. Just listen to me. One example, I will practice, remaining you can go for it. So how to express the sine inverse of x in terms of remaining inverse functions? Or else if you want, note down the question. Express sine inverse of x. Express sine inverse of x in terms of tan inverse, cos inverse, cot inverse, secant inverse, and cosecant inverse. Express sine inverse of x in terms of tan inverse, cos inverse, cot inverse, secant inverse, and cosecant inverse. Very simple, listen to it. Very useful technique this is to solve the problems. Let sine inverse of x is equal to theta. What is sine theta value? That implies x. What is sine theta definition? Not done. What is sine theta definition? Opposite side, let it is x, hypotenuse value 1. Consider one triangle ABC, let it is theta. What is the adjacent side? Adjacent side, square root of Pythagoras theorem, hypotenuse square minus side square root of 1 minus of x square. Now first we'll write by using this one, cos theta. What is cos theta definition? Cos theta definition, adjacent side by the hypotenuse. So this is square root of 1 minus of x square by 1. Shifting that cos inverse to right side. So theta is equal to cos inverse of square root of 1 minus of x square. What is theta we assumed? That is sine inverse of x. So sine inverse of x is equal to, we can write that one as cos inverse of square root of 1 minus of x square. Sine inverse of x is equal to cos inverse of square root of 1 minus of x square. So this is the relation. Sine inverse of x directly can be written as cos inverse of square root of 1 minus of x square. That is the relation between sine inverse and cos inverse. In regular trigonometry, sine theta is equal to square root of 1 minus cos square theta. In inverse trigonometry, sine inverse of x is equal to cos inverse of square root of 1 minus of x square. That is first one. Next, in terms of tan inverse. Second one. Second one, in terms of tan inverse. So write the definition of tan theta. Tan theta is equal to opposite side by the adjacent side. X by square root of 1 minus of x square. Tan theta is equal to x by square root of 1 minus of x square. So what is theta value? Theta is equal to tan inverse of x by square root of 1 minus x square. Theta means, what is theta value? Sine inverse of x. So the sine inverse of x is equal to tan inverse of x by square root of 1 minus of x square. This is the relation between sine inverse and tan inverse. Sine inverse of x is equal to tan inverse of x by square root of 1 minus of x square. So we express the sine inverse of x in terms of tan inverse. Next, in terms of cot inverse. Third one, just the reverse. What is cot theta value? Adjacent side square root of 1 minus of x square by x. Just the reverse we'll get. So theta is equal to cot inverse of square root of 1 minus of x square by x. This procedure is important. While solving the problems, we'll follow the same procedure. Theta means, what is theta value? Sine inverse of x. Sine inverse of x is equal to cot inverse of square root of 1 minus of x square by x. No need to by heart these relations, because only we expressed sine inverse of remaining 5. Next, tan inverse of remaining 5 different. Cot inverse remaining 5 different. Secant inverse remaining 5 different. So practice the procedure. No need to by heart these values. Complete the remaining 2, secant inverse and cosecant inverse. See the fifth one, fourth one. It is secant theta is equal to, what is secant theta definition? Hypotenuse by the adjacent side. This is 1 by square root of 1 minus of x square. So theta is equal to secant inverse of 1 by square root of 1 minus x square. Theta means sine inverse of x is equal to secant inverse of 1 by square root of 1 minus x square. Fifth one. Write the cosecant theta definition. Cosecant theta is equal to hypotenuse by the opposite side. Reciprocal function for sine. So 1 by x. So theta is equal to cosecant inverse of 1 by x. Cosecant inverse of 1 by x. Write the theta value. We know already this result. So sine inverse of x is equal to cosecant inverse of 1 by x. So is it clear, dear students, how to convert Like this, you can practice remaining also. Now done. Set, last set. Set 6. Sets means we divided the just similar type of theorems as one set. See the first theorem here. Prove that, very, very important result. 3 marks problems, important. Prove that tan inverse of x plus tan inverse of y, this is equal to tan inverse of x plus y by 1 minus of x into y. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus of xy. Here the condition is also important. X value greater than 0, y value greater than 0, x into y value less than 1. Product. X into y must be less than 1. If when x into y is greater than 1, that is different formula. See this one. What we have to prove? Prove that tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus of xy. So, see the solution. See the LHS we have. Tan inverse of x, one angle it is. Tan inverse of y, another angle. Let it is angle A, it is angle B. See this one. Let tan inverse of x is equal to angle A. So whenever x is, what is x value? Tan A. Second one, let the tan inverse of y is equal to angle B, second angle. So y is equal to tan B. So see this one. What we have to prove? Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus of xy. To prove this one, just guess which formula is useful to us. Tan of a plus b formula. So consider tan of a plus b formula. Consider tan of a plus b formula. That's all, over. Write the tan of a plus b formula we know. Tan a plus tan b by 1 minus of tan a into tan b. Just write the tan of a plus b formula. Tan of a plus b is equal to, we know that tan a plus tan b by 1 minus of tan a into tan b. Now see this one. What is the tan of a plus b value? What is tan a value? Tan a value x. Just tan b value y by 1 minus of tan a into tan b x into y. Applying the inverse function definition, sending this tan to right side. So a plus b is equal to x plus tan inverse of this is, tan becomes tan inverse of x plus y by 1 minus of xy. Write the a value and b value. What is a? Tan inverse of x. So it is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus of xy. When this result is valid, conditions compulsory. It is one more question, important condition. If tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus of xy, the conditions for x and y, x greater than 0, y greater than 0, x into y, the product must be less than 1. No done. Second result. Prove that. Prove that. Prove that. Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus of y by 1 plus x into y. Conditions are x greater than 0, y greater than 0. Your condition is only this one, x greater than 0 and y greater than 0. That's all. Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus of y by 1 plus xy. In similar way, prove this theorem. Very simple. Same way. Let tan inverse of x is equal to angle A. So x is equal to tan A. Next, tan inverse of y is equal to angle B. So y is equal to tan B. Y is equal to tan B. What we have to consider here? Just guess this one. Consider tan of A minus B formula. Tan of A minus B formula. What is tan of A minus B formula? Tan A minus tan B by 1 plus tan A into tan B. Because we have to prove A minus of B value. So we are considering tan of A minus B. Now write the values. So the tan of A minus B is equal to, what is tan A value? X minus of y by 1 plus x into y. Sending this tan to right side and write the A and B values. What is A? Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus of y by 1 plus xy. That's all. Dear students, once again I am suggesting you, practice is so important. Practice is so important. Otherwise, these classes will be waste. Okay, I hope that all you will follow my suggestions. Thank you.